So I recently bought this web camera, which I'd like to start using for live circuit demos. And it looks like it's going to work out pretty nicely. However, this clip doesn't provide very much height. And I wouldn't expect it to for normal web camera purposes. All it does is clip on your monitor. But I would like to be able to have it kind of hover over my circuits that I'm showing. So one simple solution would be to just set that on a book, but I don't think that's very elegant, and I know I can do better. So what I'm going to do is design a 3D printed perch for it. So the first thing I do in this process is I design a sketch. So this is like literally just a sketch of something I wanted. So you can see it is like a bird's perch. So there's this little square arch and a stand. And I'm planning on printing this assembly in two parts. It'll be the perch and then it'll be the stand. And the reason for that is printing it all together, 3D printing it together, would be somewhat difficult because if I were to go from top to bottom, from here to here, there'd be a large overhang here, and that's pretty hard for 3D printers to do. If I were to put it on its side, it would also be impossible because I have a flat edge here, and then I also have a flat edge here, and so this overhang would just be impossible to do. So next, now that I've got my sketch, I want to actually start designing it. So I'm going to design in a software called OpenSCAD. And so open comes from the fact that it's open source, and SCAD is scriptable computer-aided design. So the scriptable part can be very appealing to people with a programming background or maybe electrical engineering background where you have more programming than mechanical knowledge. So whereas in something like a popular software like SolidWorks, you're clicking on shapes and drawing lines on shapes and extruding from that, instead in OpenSCAD, you're dictating what your model is going to look like by a script. So right here, this is the preview interface, and this is the script interface. And just as a quick note, for those of you who have never used this before, though it may be a little intimidating because it's a little different than anything you may have seen before, it's very helpful to go to this cheat sheet. It's just openscad.org/cheat sheet, and it has all of the commands that you would ever need. So over here you can see your 3D primitive objects or your basic shapes like a sphere or a cube. Then you have your transformations, so how to start turning your simple shapes into more complex things. So what we want to start with is just putting a simple extruded rectangle, and so we do that by using the cube command. So let's put our cube, and like I said, this is very much like a programming language, so you have to make sure you get your syntax right, or you might not be able to render at all, or things may render incorrectly. So I've typed in cube, and this is for all the arguments, and the first argument is in these brackets, and this argument is the size of our rectangle. So what I want to do is I want, in the x-axis, I want it to be 80 millimeters. In the y-axis, I want it to be 70 millimeters. And in my z-axis, I want it to be 15 millimeters. So this is all we have to do in order to make this cube appear. So there's two buttons to see what this is going to kind of look like. There's the preview and the render. And we'll see later in the video that render is typically the best way to see what things are going to look like. So if we just do a quick preview, we see our rectangle here, and obviously it doesn't have the hole in it because we haven't told the software to render a hole. So let's go ahead and do that now. So we're going to start using nested functions, or functions operating on functions inside of other functions, and so on and so forth. So this first function is called the difference function. So we just type in difference, and we're going to put parentheses on here, and they're not going to be used because we're not doing any special arguments. And then we need to put in curly braces saying that we need to take the difference between an object at the top row and all of the objects underneath in the code within these braces. So another good idea is to take everything inside of your difference, and we want to essentially tab it over to keep our syntax looking right. And I just noticed I had a typo there. There we go. So now we want to draw another cube, which is going to be our hole. So let's do a cube, and we want it to be 10. We want our perch to essentially be 10 millimeters for the supports that hold it up. So that means that our hole needs to be 10 millimeters less on each side, or 20 millimeters total. So that's going to make our size a 60 by 60 by 15. We keep the Z size the same. So now what we expect is to see a hole punched in the side of this. Now, why isn't it centered? Well, the reason for that is because we didn't tell it to move over, so we need to move it over 10 millimeters in the X direction. So the next command that we're going to use is the translate. So this time we are going to have arguments for this command, and that's going to be in the square braces. And you want to move it over 5 millimeters in the X direction. So we just type 5, 0, 0. Now also, we need our curly braces. And I'm going to push tab here to keep our syntax looking pretty. So it looks like I misspoke. This number is actually supposed to be a 10. So we change it to 10, render it, and there we go. That's what we expect to see for the first part of the assembly. So now we need to start working on the base of this perch. So we're going to go down here, and we're going to make a new extrusion, or use the cube command. And this is going to be 90 millimeters by 10 by 40. Oops, so you can see right here, this is the result of clicking preview. And so you have to do some certain precautions to be able to preview things properly. So I found that the render is sometimes just a better bet. So we look at this, and it's probably not going to work. I expect that the model would tip over after it was printed when I clamped the camera on there. So what we need to do is we need to move this base over in the negative X direction, and also in the negative Z direction. So once again, we're going to use the translate command like we used on the hole before. So let's type in translate. And this time, we're going to move it -5 in the X direction. So we've got right here, this gap is 10 millimeters. And so we need to split the difference in half so we can get it over here. So that's why we're only doing 5. We're not making any changes in the Y direction, so we can keep that as 0. And then for the Z direction, I'm going to use -12.5. Now, that seems like kind of an arbitrary number, but it's really not. So where that's coming from is we have 40 millimeters from this point to this point, and we have 15 millimeters, that's the width of the perch. So if we take 40 and subtract 15 from it, and then we need to divide it by 2 in order to figure out how far to move this. So I also noticed I do have another syntax error. Well, I need to put my square brackets here anytime I'm doing my three-dimensional coordinates. So now we should be good to put our curly braces around this. And I want to tab over my cube here. And let's preview this. So kind of look around and see, yeah, that's what I want. Another good idea to look at your model is you can look at different views by clicking these buttons. So I can see it's centered there. You can also see it's centered here. I think we should be good. So, like I said before, I want two parts, and so I have my whole model here, but I need to be able to split it into the two separate parts. And one of the issues becomes when I go to print the base, all it's going to be is a rectangle, an extruded rectangle. And that becomes a problem because I need to be able to plop this in there. I don't want to deal with any gluing. I just want it to be press fit. I want to kind of hammer it in and call it a day. So what I need to do is I need to make some square holes in the base. So this is pretty simple. We're going to use the difference again. So what I'm going to do is I'm going to type difference. We're not having any special arguments again. And I'm going to tab this over to keep our syntax looking good. And now, this is kind of a lazy way to do it, but it works. I'm going to take this whole piece of code here to make our perch. I'm going to copy it with Control-C, and then I'm going to paste it right here. Now I can see my tabs got a little screwed up. I need to tab like that, and now we should be good. So when we preview this, we're actually not going to really notice anything because our hole is being filled by this piece here. So a handy thing to do in order to view each individual part is to do something called commenting out. Because just like any other code, you can actually put comments in here by using the slash 2 times. So this is a comment. So I'm going to take this out of here, and what I'm going to do is I'm actually going to take our perch off because we already saw that. We knew that that's what we wanted. So I'm going to use a method called star commenting, where I do a slash star, and I do another star slash. You can see that this is green now, and the code below it is still colored. So now when I render it, I can see I've got a nice base with 2 holes in it. So now all I really have to do is export to an STL with this commented out, and I need to comment out the bottom code and export the perch to an STL, and then I should be good to print. The parts are all done, and they look like they turned out pretty well. However, my last issue is that this doesn't fit. It's just a little too tight. So I can either take a Dremel or just some sandpaper and sand this down until it fits in there. So here's the finished camera perch, and it looks like it's going to work out pretty well. So this is just an example, one of the many examples of why, one, having a 3D printer can be very helpful, and two, having a little bit of CAD experience can go a long way, because these are just extruded squares and I can make pretty useful things very simply and pretty quickly.